Hello, Internet. How are you? Kevin, my friend, how are you?
I'm well. How are you tonight, Sam?
Not too bad, not too bad. Yep, good afternoon, good evening. Hopefully, it's not morning for you anywhere because it'll be way too early in the morning, some parts of the world. But welcome back to Code It Live. This is a slightly different type of stream because you're not going to be stuck, watching me fail at coding. You're in better hands today.
No, you're gonna watch me fail at coding. It'll be fine. I got the gist.
Yeah. But this is going to be a little formal because this is a user group meetup. We used to have this group in person. Now we do all things digital, as one does. So I'm your host for the day, Sam, and with me I have my wonderful friend, Kevin Griffin. And before I hand it over to Mr. Griffin here, let's talk about what it is that we are about to talk about. All right. So let's see if technology works today and I can share screens. Present my whole screen somewhere there, share, and that. And let's go full screen on this. There we go. All right. So welcome, everybody. Welcome. This is I think, Kevin, I may have mentioned this to you, but doesn't hurt for the giggles. Again, this is a user group, but there's been quite an evolution. We started with Windows Phone back in the days. Like we spent a good couple of years on that. Then we thought, yeah, let's just call it Windows, open it up to everything else. And then we started talking more about JavaScript and AR and VR and all the things. So we said Columbus App Dev, because we are essentially based out of where we started out based out of, Central Ohio. So we thought App Dev doesn't get, more generic than that. And then the pandemic happened and we're like, we're not really tied to Columbus anymore. I guess it's open to anybody. So now we are global, right? So unless we go to Mars or do anything else with any other planet, I think we are okay with global for the time being. But you can find us pretty much online. Let me look at the chat room here just to make sure I'm not missing anything. Um, I see chat room here that I have been ignoring. Hi, Liz. Is that
It's my son Eli on my wife's account on the iPad. I guess he got a notification. So hi, Eli.
Yeah, there we go. And Code with Sean is here. Yeah, hey, yeah, you know us. Hey, everyone. Hi, Dad, again. Hi, it's Eli. Oh, that's cute. That's cute. So Dad better get his act right today.
I know.
Does Dad stream with the kids with anything video gaming?
No, Eli's my little gamer buddy, and we don't stream. I don't. Yeah, I don't let him do that
Eventually,
yet.
yeah.
We've talked
Eventually,
about it,
Eli,
but not yet.
you'll get to it.
One day.
Yeah. Anyway, so this is the Global App Dev user group. You can find us online, pretty much all the usual places, and we meet right here, third Monday evenings. Although we actually haven't met for 2 months now during summer, so Kevin is getting us back on the groove. So let's see what else. We do have a few sponsors who are going to help us out with the platform, with some digital swag that we do sometimes. Visual Studio Live, we'll talk about that event-wise. But we always, mention a few things that are going on, around us. Kevin, you're in Northern Virginia, right?
That's right. Yeah.
Yep. And I'm in Northwest Pennsylvania. So we cover some of the things that are close by. This is coming up, I think, next week, actually, DevUp. This is in St. Louis. 3 days, solid, regional conference, lots of speakers, lots of attendees. So it should be a good time. This one is not anywhere close to the Midwest in the Americas because this is actually in Europe. This is in a lot of us folks who put together this conference in Eastern Europe, Sofia, Bulgaria. It's our engineering headquarters, and it's a good time. So that's coming up in late October. And .NET Conf for all things .NET. 2023, it's going to line up again with the .NET 8 release. And Kevin, correct me if I'm wrong, I think their call for speakers is out. So if anybody wants to speak on anything related to .NET, they are always looking for experienced speakers as well as, speakers who are starting out. So, give them a shot. Go ahead and submit. Anything else I'm missing, Kevin, that's coming up in the near future?
You have everything I'm aware of. I've had to keep my fall pretty empty, but yeah, nothing really for call for speakers until next year.
Yeah, well, we have had a busy summer. Oh, and then
Yeah,
I think Dev Space is coming up. That's our good friend Chris Gardner down in Alabama. I think that's late October as well.
late
But
October. Yeah.
I might be mistaken. Okay, good. All right. So speaking of VS Live, these are bigger developer shows. Almost a week long, and they do it across multiple cities in the U.S. We just did San Diego last 2 weeks back, and the next one that's coming out, it's actually the biggest one. It's in November, mid-November in Orlando. So again, if you're a company or if you want to come and hang out in Orlando for a week, this may be a good option. If you are, you get a big discount for being a user group, user. Looks like I missed something here. Code with Sean. Yes, thank you for reminding us. That conference, our good friend
Yep.
Clark does two of these. One is in Wisconsin Dells, one is in Texas, in Austin, right? Yeah. So that Austin one, which is in January, that CFP closes today. So thank you, Cody Richon. Thanks for the reminder. I don't think I have submitted yet, so I might be doing that after dinner.
I put a couple in today. Sean reminded me about it last night. So
good,
fingers
good.
crossed.
Oh, and look who's here to heckle us. Our good friend Joe.
Joe.
How are you, Joe? How are you? Yeah. All right. Round Rock, Texas. Yes. Kind of close to Austin. All right. Cool. So, yeah, that's what's going on. And with us today is the glorious Mr. Kevin Griffin. Yeah. And Kevin, I've known you for a long time, but you're amazing. You're doing your thing with all the technologies. You're a speaker, amazing, speaker, just an all-around swell guy is all I could say. So you are here to talk about background services, the really difficult stuff.
That's my goal.
That's your goal. All right. So enough of me. I'm going to hand this over to Kevin here. So your screen desktop is coming right up, and
All right.
the stage is yours.
All right. Well, thank you, Sam. Thank you, Progress, for hosting us, and let me come to all the good folks out on the internet on this evening or morning or wherever you are in the world. I know at least Sean and Joe and my son Eli are with us, and that's really all I need. Today we're going to talk about building background services in .NET. This is one of my favorite talks to do. I've done it at a handful of different conferences and other user groups because this is a topic that not a lot of folks know a ton about. They just kind of assume that it happens, or they go into a team that's already solving the problem one way or another. And I like bringing things back to basics. So let's talk about building background services in .NET. And like all good things, we need to start with a story. And usually when I do this at a conference, I use this analogy of we have this amazing speaker up on the stage, and he or she or them are talking about some awesome topic, and they have all the eyes from the audience. But in reality, as the speaker at DevReach or that conference or CodeMash or wherever, the speaker is literally the least important person at that time. We forget about all the people that make a conference actually happen. So in the room with the speaker, it's not necessarily the person up on the stage, it's the person behind the stage that's maybe managing the sound, or they're running a camera. They're making sure that the lights are the right level. It might be the person out in the hallway that's picking up trash and emptying trash. It might be the person preparing food for lunch later that day. There might be people just walking around making sure that everyone has water to drink. It takes a lot of background processes in order to make something like a conference happen. And that doesn't make any sense really in the aspect of a virtual talk like this. But if we were at a real conference, it would make a ton of sense. And I think your application is very much the same way. Let's assume that this is an application you've been working on. It's not an application I've been working on. It's just a screenshot I stole off the internet. But this is the fancy speaker up on the stage doing the least important work, in my opinion. Their job is to dictate some things that you want to buy and collect a little bit of information from you in order to buy it. And the story really starts out. I used to work on an application a very, very, very long time ago. I didn't write the code. I kind of walked into the fire as it was all happening. But our process for handling a payment form sort of like this was fairly straightforward. We would handle a click to the Pay Now button, and it would go off and run a little bit of a workflow. So we'd create a brand new order. The process would then go check available inventory, make sure we have everything in stock that's necessary. We would charge a credit card and make sure that all happened. We would send an email to the person telling them that the order had gone through and they should expect a shipment soon. And we come back and say success. Awesome. However, there was a bug. And in this entire workflow, there was a chance that sending email would not work correctly. It would it would throw an exception because SMTP servers would go down occasionally. And when that happened, the user wouldn't get the success screen. They would get, hey, there was an error processing your order. But it would be an error processing their order after we had charged their credit card, which is not the proper workflow that you want for a small e-commerce application. Like I said, this was a very long time ago. I didn't write the code. I just came in to help fix the fire.
But it's a good point though, because like whether it be background or foreground, like Sean is saying, like stuff has to work first. Right?
It does, yeah. It needs to accomplish the job, and then you can go back and fill in all the blanks after the fact.
Yeah.
So this is where I usually come in. I go, hi, everyone. My name's Kevin. Those of you who have never seen me before in person or virtually, I'm a Microsoft MVP, and I love developing solutions in .NET, specifically ASP.NET Core. I love deploying solutions to Microsoft Azure, and I love anything web development. So if any reason you want to talk to me about any of those subjects or more, feel free to reach out to me in one of the multiple ways I have up here on the screen. I also have courses that I do on the side. My biggest one is my SignalR Mastery Talk, which I talk about real-time web development. I'm going to drop links to this stuff here a little bit later. If not, you can scan the QR code. And most recently, I released a course on building background services in .NET with Hangfire, which is actually really good about this talk, is because I talk about Hangfire as one of my many solutions. But again, we're not going to talk about that right now. Scan the QR code if you're interested. If not, I'll give you a link later. But let's go back to the fire. And how would we approach this a little bit more logically to prevent this case where I don't want to send an error back to the user when something like email catches on fire? Instead, I send them still just a success screen. Everything happened all right. And I can deal with the email issue a little bit later. Now, this isn't going to be a hard, fast, this is how you have to do it. It's just a general guideline of how a workflow might work in your system. So let's go all the way back to the beginning of the Pay Now button. And you say Pay Now. We go off and we still create the order. Now, this is very synonymous to if you order anything on Amazon. And I'm pretty sure each and every one of you out there have ordered something on Amazon at one point in your life. When you order on Amazon, you don't get back a shipping confirmation immediately. You get back just an order confirmation. And that's what we want to do. We just want to confirm that we received the order. We received your request to buy stuff from us. And that's about all we've been able to do. So success. But at the same time, we're going to go off to the side and we're going to set up a variety of systems that do the extra work behind the scenes. So the first thing we might do is check that inventory. Once inventory is good, the workflow will go off and charge the credit card because that's still a step you want to do. Sometimes that will fail and we can go back and we can send the user an email saying, hey, please update your credit card. But if finally, when everything's all good, we know we have the inventory, know we have charged the credit card successfully, we can finally send that email telling them, hey, everything's good, we're moving forward. And if for some reason the email fails to send, we can wait a minute. We could wait 2 minutes. We could wait 10 minutes. We could wait a couple hours. Eventually, that SMTP server is going to come back up and we can send the email successfully, or an engineer will have gotten a notification saying, hey, email server's down. Go back and check these orders and make sure they get sent. So that's the general concept of doing work in the background. So let's divide background work into just two general buckets. The first is going to be background work that we want to do on demand. And this is stuff like processing my workflow, go off checking my inventory, charging my credit card, etc. Sending my transactional emails, so this order was successful, or sending an email that we need a new credit card. That's all stuff we want to do in the background. Maybe I need to alert other systems. So I need to put something on a service bus, or I need to instantiate a webhook to send a notification. Sometimes I need to go through and do some cleanup. So we have systems where we're continuously ingressing new data. And as that data comes in, we kick off processes to go clean up, making sure that their city, state, country data is all correct. Make sure they're set in the right time zone. This is all stuff that we do on demand as the data is coming in our system. But it's all completely separate from the work being done in the user interface. It doesn't affect the users at all. It's all happening over in its own little silo. And if it crashes for any reason, the users don't know any better. Now, we also have background.
Kevin, sorry,
Yes.
Quick question. So when you talk about background actions like this, like you're not talking threading, you're just talking simply just stuff that's happening in the background that the user doesn't need to know right away. However, like if things need to be like, transactional, where something fails in the background, like would you have to, are you talking about having more background tasks that will roll things back to a state that's acceptable?
Potentially, yeah. The biggest reason we're even having this discussion is that we don't want things to happen where it could potentially affect the user. The user should have this very ignorant view of all the systems working in the background. So if emails fails to send for any reason, the user doesn't need to know that. That's something that we just need to handle in the background. We're going to go a little bit more depth into this, but there's things like retry. So if something fails, can I retry at a later time? We'll talk a little bit about transactions, but you're right. If I'm working through a workflow and something fails, can I roll back to an earlier state so I'm not compromising any of my other data? Absolutely. This is all stuff that can happen in background services. All right. So we talked about stuff that you can basically do on demand. And then you also have background tasks that we call reoccurring or scheduled tasks. And these are things that are going to happen on some sort of schedule. We could set our watches to them. So specifically, I like to use the term reoccurrence because it's going to reoccur every hour, every day, every week, every 6 months, every 2 years. I used to work on a system where we did reoccurrence. Every 2 years was a possible reoccurrence point. And boy, that was a pain in the butt to test because you had to set up a system that would basically test for a case of if we had something that needed to run every 2 years, we were properly handling that case when it came up. Luckily, there weren't that many of them. But this is stuff that we want to do all the day and you do all the time. You probably have systems like this in your applications. If you ever had a scheduled report, I have at least 6 of these that are currently getting ready to run in the next hour or so. And they'll go off, they'll collect their data, They'll do a little bit of aggregation, and they're going to send an Excel document to one of 5 users. We have some resources that we clean up in the background. So every day we're filling up blob storage or queues or database tables, and we have regular tasks that go and make sure that we're cleaning up after ourselves, so we don't accidentally use more data than we absolutely need, or in some cases, accidentally spending more money than we necessarily want to spend. So stuff that you want to do in the background on a regular reoccurrence. Now, as you jump in to figure out the 2 types of background tasks that you want to build, you also have to consider where you're going to host these background services. I know this is the global app dev user group, but if you're building a Maui app or a WPF app or WinForm still around, you're building a WinForms app, you might not necessarily want to go build a background service that runs in the cloud. You might want to build something that runs locally. So a Windows service might be the best approach for you in a lot of these cases. Or building a Windows scheduled task that goes and runs an executable. That's a perfectly good example. You might want to include background services inside your app. So if you're building a new .NET application, there's this thing called the .NET host, and you can build a hosted service inside your app. So as long as your app is running, it can go off and do all the work you want in the background, and it doesn't really affect anything on the user side. I spend the primary most of my time on the web, so I'm developing a lot of ASP.NET Core apps, but I can use the same technology as I would for a local .NET app with iHosted service. Use that same thing inside of ASP.NET Core, and I really don't have to change any code. It's literally copy and paste from one to the other, and they work exactly the same. Mentioned earlier, I use Azure for all my deployments, and I'm a huge advocate of platform as a service. So I'm using a lot of Azure Functions, Azure App Services, and a variety of other things. But those are also good candidates for cases where you want to run background services, maybe at scale, and you don't want to have to worry about managing all that infrastructure yourself. I also want to talk a little bit about resiliency. So if you run a background service or a background task, what happens when it fails? So the number one thing might be, well, if it fails, we want to retry it later. If it retrails multiple times, how many times do you want to retry? What happens if you retry 3 times and it fails? What do you do next? Just something you got to think about. What happens if your service host crashes? So if I'm running a background task inside of a .NET 6 application and the entire process crashes, what do I do to restart that process? Talk about a couple of ways to handle that. So this really breaks us down to our agenda for the rest of this talk, and that's going pretty deep into a variety of tactics, which are just tools in your toolbox for how to do background tasks, background services in .NET. And specifically, we're going to talk about hosted services inside of a Windows service, which you probably have not talked about Windows services in over 10 years. I know I hadn't until I was researching this talk. But that conversation will also lead us into ASP.NET Core hosted services, which are amazing and I use all the time. We'll talk a little bit about a couple libraries I've used professionally more than 2 or 3 times. One is going to be Quartz. The other is going to be Hangfire. And then as time allows, we'll talk about Azure Functions at the end for cases where you might need to break away from some of the earlier examples. Now, I'm going to stop everyone here. You might be thinking, Kevin, what about insert the library or framework of your choice? I'm not saying this is the conclusive, the only ways you can solve this problem. There are other ways available. There are actually ways I've learned about since doing this talk, but I'm just too lazy to add them to the slides. So we're not going to talk about them.
That's funny. No, but I mean, you spoke a few things, to me. There are differences across platforms if you want to do this, like on mobile versus desktop versus web. Very different ways of doing things, but it's
Yeah.
all the same idea.
Same idea, just different ways to do it. And actually, yeah, if we were on a mobile platform, I'm not entirely sure my processes would work there. I've done very little work on mobile platforms. Um,
Yeah,
so
I mean,
that'd
it's
be a
it's it's no different
conversation
from
for
what
later.
you mentioned. Like within your client app, like both iOS and Android do this. Like you can schedule things that will run on a background thread. Now, I mean, it's slightly different than just a background process. But I mean, the OS will give you little cycles to go and run your code and fetch some data or do a push notification, things like that.
Yeah. All righty. So we have our tactics. We know what we want to talk about. Let's go ahead and dive into our first concept, which is .NET hosted services. And let's kind of talk about this from the beginning. I believe .NET hosted services were introduced back in .NET 2 point something something. I don't keep track of any of these versions, so sorry. But a long, long time ago in .NET Core land, they added this concept called the .NET host. And the .NET host is your application and all the things that your application can do. And what we can do inside of our .NET host is I can spawn these things called hosted services. So a hosted service is, think of it like a thread or like a sub process. It's just this sub process that's off running, and it's going to run basically for as long as you need it to, or it'll run forever for the lifetime of your application. Really depends on what your goal is. As a startup, it has a shutdown, it has full dependency injection support, but it runs inside your .NET host. What's really cool about these is you're not limited to just one. You can have a bunch of them. And we do this all the time. We'll stand up little hosted services that do one thing, and we run them at the beginning of our application. And they might run for a minute or two and then shut down. And then we might start them up again a little bit later. Or we have some that we start at very specific times of the day. And then we have others that just run all the time. You can use these any way that you want to. They're super efficient. And, well, they're super efficient as long as you're not doing bad stuff. If you are just a horrible coder like I am, it's probably not going to work out well. But
So you had me a little confused because like Joe was weighing in on when this was added, like two point yada yada something. So this is not the .NET generic host, like the DI system that we use to bootstrap our apps. That's not what you're talking about.
it
Or
is.
is it?
That is
Is
it.
it?
Yeah.
Oh,
Yeah.
okay.
Yep.
Okay. I thought that was a
Yeah.
new word. Like that was .NET 3 forward, like since .NET Core came along.
I
Maybe
think
I'm wrong.
I think it was one of those cases where they put in the framework for it in 2,
Let's see.
but then they actually figured out what they were doing in 3. I'm sure someone could go on Wikipedia and find the real answer to it. I'm at the point now where all the .NETs just flow together, so it's all .NET to me. But yeah, it's the idea of it doesn't matter what platform I'm running on of, as long as I'm running a .NET host. It could be a WPF application. It could be what Maui, I believe, is .NET host. It could be a Blazor application running on inside the browser. It could be just ASP.NET Core. Like the .NET host is fairly generic, and things can run on top of it. And then you can just run it anywhere, which I really love and appreciate. And that's actually the first demo we're going to do. Which let's talk about hosted service a little bit more. So there's actually 2 ways to run a hosted service. You can implement it yourself. I hosted service. Don't think I actually do that in my demos. Or you have this more abstracted way, which is the background service implementation. And what you can do here is you implement just a single method, the execute async, and this will do work until it's either done, or you do like I do and just add a while loop and do work forever, as long as your process is running. And you can do whatever you want to in here. And this is going to run in the background of your application at the moment that your application starts. This is done inside of your startup, your program CS, wherever your application is bootstrapped. You can add as one of your dependency injections, add hosted service and give it the type of the service that you're building. And .NET's going to take this, run with it, and handle starting it up, making sure it runs to completion, and cleaning it up when everything's all said and done. So let's jump into an example that uses Windows Service. And I know a lot of you probably have never thought about Windows Services before. Let's date some of ourselves. I have written an actual Windows service in the past the hard way. And the hard way being you used to have to write an application executable that knew how to handle 1, 2, 3, 10 different command line arguments. And a long time ago, it wasn't documented very well. You had to go through some Windows API documentation, and they would tell you, oh, handle the /s, and that means something, or /I means something else. And if you ever learned how to do it, you would do it once and never do it ever again. In the .NET ecosystem, there was a great library a long time ago called Top Shelf, and Top Shelf abstracted a lot of that stuff away, and it was great to use. But now it's actually even easier than it ever was back in the old days. So I have an application here called Cleanup Service. And what we want to do is we want to go build a background service. So as the application's running, I want to go check a folder. And if there's ever anything in the folder, then the folder is going to be ctemp. If there's anything ever inside of ctemp that's older than 5 seconds, I just want to delete it. It is the most destructive thing I thought I could demo for this crowd.
This is a classic.
So that's all it's going to do is every 5 seconds or every couple seconds, we're going to check and see if there's anything in that folder. And if there is, we're going to delete it if it's more than 5 seconds old. And that's going to run at the beginning of our application. And you'll notice up here at the top, I've added a special use case for Windows Service. And I can set all kinds of configuration for my application here. But notice I'm not going to go install this as a Windows service yet. I'm just going to go out to command line and I'm going to say .NET run. So I can debug this entire service from the terminal as I wish. And if we sit here and wait, I forgot what I said my point to, but we'll see. I'll go open my folder real fast. And there's nothing in this folder. I want to add a new file. We'll just do a new text file. And if we sit here and wait. All right, found one file, delete. It deleted the file. Cool. It did the one thing I wanted it to do. Nothing special.
So
now that's
Kevin, you can improve on this demo a little bit. Might be because our good friend Blazor Mr. Magoo is here. Hello. My tablet below the screen is connected to the Blazor app that's running as a Windows service.
There you go.
And essentially, what Blazor Mr. Magoo is saying is instead of the folder to check, ctemp, we should set that to system.
Yeah. Every 20 minutes, we just format C /Q, and we'll be done with it. I understand.
Can you talk about code which Sean is saying, MSMQ?
Yeah. So Microsoft messaging queue. I have not used MSMQ in a very long time, but it was as I recall, just a basic message queue built into Windows. That you use, so you could pass messages between different applications, and it's like microservices before you had cloud infrastructure. So if you were just trying to do things locally, you could have application A talk to application B over MSMQ. I think it started dying out during the, I don't know what, the WCF days. So Windows Communication Foundation. I don't know. That's a tale for a different time.
And in the chat room, Mr. Penjara, we see your question, and I think Kevin, you run your own business, so but it's a separate conversation. So maybe we can circle back to have a more general conversation towards the end. Yeah.
Alrighty. So let's take this concept, and I told you I was building a Windows service, but I didn't run a Windows service. I just did .NET Run. So everything's at the terminal. Let's take this example, and I'm going to open up my Windows services real fast, and I'm going to show you that there's nothing in here called tactical whatever I'm going to call it. And we're going to go install this application. So .NET build. Let's do a .NET publish. And all right, so we have a location here.
I'm just jealous how quick your builds are, because I'm used to like .NET MAUI. It takes like a few years to build.
My secret is my applications don't do anything. So it's amazing how fast your builds are when your applications don't do anything.
Oh, no. I'm just checking.
I'm going to open up a command prompt as an administrator. That's kind of the secret sauce here. And what we're going to do is also go look at my README for this application, because I never remember this by heart. Yep. All right. So we're going to say sc create. So this is talking to the services on my Windows machine. We're going to call this tactic Windows service, and we're going to set the bin path equal to that long path / tactic.exe. So we're referencing the exe. When I hit enter, we see, create service success. Yay. I go into my services, refresh, do a zoom in here. I have my tactic Win service. I didn't set it to automatic or anything because I don't want that running all the time. So let's go ahead and start it. And this is now running the application in the background as a Windows service. So I could technically open up my temp folder. Let's create what did I do? Text file last time. Let's do a Word doc and just hit enter. So there's a file in here. And now I don't have any output telling me last time it ran, if it's running now. We could pipe things to the event viewer if we wanted to, but basically we're going to sit here and wait a moment, and boom, the Windows service went through and it cleaned up my folder just as I had asked it to. So yay, it's doing the one thing it was designed to do, but it's doing it as a Windows service, not as a regular .NET application. So this is really nice. No one has to be logged in. I can install these on Windows servers if I'm managing my own Windows servers. There's a lot of different use cases here. And like one of the viewers was saying, you could technically host like real applications inside of a Windows service and expose different ports and such. So have a web app that's running as a Windows service. You could totally do that. All right, I'm going to stop that service so it doesn't mess anything up in the future. Jump back over in the slides real fast and answer the two common questions. The first one is, what do you install? You go to NuGet, install Microsoft extensions, hosting Windows services. I'm pretty sure this is getting ready to get bumped to 8.0, so I'll have to update my talk. But you install that package, and that gives you the access to the use Windows service extension method, so you can do all your configuration. The couple of pros, I like pros and cons of different approaches. The big pro to this approach is I think it's really easy to build, especially compared to how we used to build Windows services. It's much easier. Windows will automatically manage the entire lifecycle for you. It makes sure that your Windows service starts up. If it were to crash for any reason, it will automatically restart the Windows service if you have it set up to do that. So super useful. A couple of cons, you're limited to the machine you're running on. So if you're looking for cloud scale, you're probably not going to get it with this approach. It's also, we didn't really talk about like easy ways to do on-demand work or doing scheduled or reoccurring work. And it's not that you can't do it, it's that you are responsible for writing all the infrastructure in order to accomplish that. Sean mentioned MSMQ earlier. You would have to wire that up and then build a background service or a background worker that would listen to the queue for messages, pull them off, and go through and process them. You still have to go write that. So not as straightforward as we necessarily would want it to be. And what happens if my delete task crashes for any reason? Well, the way it's currently set up, if it crashes, it just stops doing the work. It's not going to automatically restart itself. I could try to get around it by putting a try catch, doing some error reporting, and then just pretending like nothing happened. You can also go talk to the orchestrator for background services and have it restart it if anything were to happen. There's a blog post somewhere on that I'd have to go look for. But you're still responsible for the worst case scenario if they were to occur. If you're running on Linux, you can also use the systemd package that does the exact same thing, but on Linux, not a Windows service. I have not done this, but I've heard people say good things about it, that it's fairly well supported and works just as well as the Windows service stuff does. I've been meaning to do a demo on it, but I just haven't had time. But it's there if that's a use case for you. And again, go to the show. When .NET is a truly cross-platform system. And this is, yeah, you can do a background service on Linux with .NET. That's pretty amazing.
And I was just looking this up because I was blanking on the name. On macOS, you can do a similar thing. It's called LaunchD, kind of like systemd. Yeah, same idea. It like manages like daemons and agents, like not actual daemons, but background services and processes.
And it's all .NET, which is amazing. Alrighty, well, let's move on to the web. My platform. I love building ASP.NET Core apps. So let's take the same idea of using a hosted service. Slightly different syntax as we had a little bit earlier, but the concept's exactly the same. Instead of just the regular .NET host, we have the web host, which is the same concept. And we're going to use our hosted service in a web app. And the example on the screen, we're not just cleaning up a temp folder, but we're also listening at endpoints, or we're setting up controllers, or we're exposing a Blazor server. Like, you name it, this app is going to do a lot of work in a lot of different aspects, but we can tell it to do things in the background as well. So no more slides. Let's jump back in the code. Now I'm going to close this example because we don't need it anymore. And I'm going to open up another example. And first thing I'm going to show you is that this app is the exact same concept. I tweaked the code a little bit because it's a web app. It's still implementing background service, still implementing the XU async method. It's still doing the cleanup inside of a folder. I have a little bit more logging, but it's also getting a temp path from the OS instead of just assuming it's going to be C temp. This is probably a little bit safer method if you're running a web app that's in a protected environment. So let's go get a temp directory and check it every couple seconds for some files. If we find the files, let's delete the files. Exact same concept. We set it up. You just saw the slide for this. This is an ASP.NET Core app. We're going to set up the hosted service to run cleanup temp folder service. And this will run at the beginning of the app and just run indefinitely until this either crashes or I shut it down. Oh, we don't need that anymore.
So on that front, quick question: when you say when you set up something where it's perpetual, especially on a web server, do you care or do you worry about unnecessary cycles being wasted? Because if your hosted service isn't doing something every let's say 2 minutes or something, you're going to spend some things on your IIS server just trying to run that.
I do. So what I do is most of our services that run for the lifetime of the process, we're doing a while loop looking at the cancellation token, because the cancellation token is going to fire as the app is shutting down gracefully. I don't know about you all. I've never had a web service shut down gracefully. It's always been me doing something dumb and the service just crashing. So, I mean, but it could technically shut down gracefully if the OS is restarting for any particular reason. But the big thing that what I do is we have a delay using task.delay. So we're basically telling the OS, hey, go off and do other work, but come back to us when you can a little bit later. And what we have found, and this is just in the work that we do, we don't have to spend a ton of time here. We'll go off and check a message queue every second. And that little delay is usually enough that we can let the systems go off and do everything else that they have to do. And this is processing thousands and thousands of requests per second for all of our customers coming in. So we have never had a big issue for this. I would never do a sleep here, like a thread.sleep. You used to see people do that all the time. That's a bad idea. I wouldn't do that. But task.delay, we usually never had an issue there. And also pass that cancellation token around to anything that will support it. So if something were to start to shut down, everything's handled across the board. And I guess, yeah, to that same point, make sure, like, if you have any other loops inside of here that are resource intensive, be responsible. So don't spend too much time doing process intensive stuff in here. The other thing to look out for is, we didn't really talk too much about it, but you have a dependency injection pipeline. So you can inject dependencies, but these are injected at the time the service starts up. So if you're injecting something that should have a short lifespan, say a database connection or like a SQL connection, you might not necessarily want to inject that here. You might want to set up a scope inside of your execute. So only allocate the resources to the database at the time that you need to go talk to the database, and then let the garbage collector go do what it's going to do.
Yeah, you speak from experience, because whenever we talk about DI, people are either let's just new up something every time or throughout the lifetime. But scoped has its place.
Yeah.
So Kobach was talking about the orchestrator. Process matching, managing other workloads like the background services. So is this like the shortest and the most precise definition of Kubernetes, pretty much?
I mean, yeah, probably.
Yeah.
Except people actually understand this stuff. No one understands Kubernetes.
Nobody does. Yeah.
Good time. Any other questions?
Yeah,
Sean. I see Sean laughing. All right. So this long drawn out conversation is all to say, I'm taking the pretty much exact same code from the last demo and I'm putting it into an ASP.NET Core app. And we're running that app. So it's sitting here and you can see my log spitting out. It's this time and I'm doing background work. So let's go to my temp directory, which is right here. Slightly different location. And this is a more process safe temp directory. I'm again going to add a new file. So we'll say new PowerPoint, hit enter. And I know this is probably difficult to demo remotely for y'all, but we'll do our best. All right, so it just ran. It cleaned up the file. Yay! It did the thing it was supposed to do.
So compared to a Windows service, this is literally an ASP.NET web app, but it's registered to run this based on however you schedule it. But it's just a hosted, OS is giving you that cycle to go run this.
Pretty much. The process, it's still running the exact same process as we had in the Windows service. The biggest difference is this is running inside of a web process, so it's probably behind an IIS server somewhere, if I was running this in Azure, it's behind what Kudu and all that magic that makes Azure work. So that's the biggest reason I'm using the slightly different temp directory. I'm asking the OS for a temp directory because I might not know where my temp directory is. The OS has to tell me. But other than that, it's the exact same process. As my counter ticks over, my task.delay runs. It's going to go check the folder. If it meets the criteria, it's going to delete the files. And it's safe. It's not system root. like the viewer wanted me to do earlier. So, but again, we run into the same little issues that we had previously. Let's jump into our slides again. But first, just the pros of this approach. Again, it's really easy to build. I run probably 4 or 5 of these in our web applications because they do one job very well, and I can just get them in process. Sam, you were talking a moment ago, just like responsible usage of your resources and making sure you're not killing your service by doing this. I would love to talk about that. That's a whole nother hour talk. I wish we had time for it. Maybe one day. Maybe I'll come back in a couple of months. It runs really well inside of our ASP.NET Core host, which is the same as the .NET host we had for the Windows service. And again, it starts up automatically as the app starts up. Couple cons: you're still responsible for scheduling. So I could write something that just checks the time every second and goes and does work when it is at the top of the hour. I want to show you an example with Quartz, which is a high precision scheduling library in .NET. Works really well. I've used it numerous times. The other issue is you're still responsible for resiliency. What if that process crashes? What if the process crashes? I have to restart it on my own, or I have to restart my ASP.NET Core app. That's still all on me. So we haven't really gotten away from that issue yet. We also didn't put in here, there's no real concept for on-demand tasks, which is still a big issue. I would have to listen for some sort of message coming into the app. We use queues all over the place. So if a message comes in from a queue or from a service bus topic, we'll go off and do some work. But we're still responsible for setting all that stuff up. So let's move on to scheduling. And I specifically added a topic in here for Quartz because Quartz, I wish I could go back and talk about the history of Quartz. Quartz is one of these Java libraries that came over to .NET because it was a good idea and people wanted it in .NET as well because we didn't want to do Java. Not that there's anything wrong with Java. It's just, it's not .NET. So what is Quartz? Quartz is basically a high precision scheduling library for .NET. And it really comes down to 2 key factors. You have jobs, which is work to be done, and then you have triggers. So what makes the work go be done? A trigger could be on demand. A trigger could be some sort of timer. The example I have here on the screen is configuring Quartz for your ASP.NET Core app. And our job is going to be the cleanup temp folder, which is going to work durably so we can save the output for it in some sort of database and keep track of when it runs. We can make sure it only runs one at a time. So maybe I don't want 2 processes looking at the same folder at the same time. Sometimes that's something you want to do. And with this job, I want it to run every 30 seconds. So I can use cron syntax for that, which is here on the screen. So every 30 seconds, let's go run our job and make sure we're not running them twice at a time. When you're running this in ASP.NET Core, there's a little bit of configuration you got to do for dependency injection and just setting up the background server. I have the code here just for ceremony, but documentation is fairly good. They'll show you how to do all this as well. And all my sample code is available.
Kevin, questions.
Yes.
Sean is asking same cron syntax as in Azure Functions.
Yeah, to a degree. Azure Functions likes the .NET cron syntax, which is basically cron with a potential like 6th or 7th octet, whatever. You can be a little bit more precise with the Azure function cron. Quartz is based off more Unix cron, so I think it's 5. Well, I have it on the slide, don't I? It's 1, 2, 3, 4, 5, 6 octets, and Azure Functions will support a 7th.
And I have a more basic question, like to your point, like running something at the top of the hour or every 30 seconds, like it's not actually running nonstop because that's expensive. Is it using a system clock or how is it triggering every 30 seconds?
I don't know. It has its own internal scheduler. So you tell it needs to run every 30 seconds. It's going to basically start the timer from the application has started. All right, it's been 30 seconds since the last start. Let me go run this job and make sure this job runs. If you have something like we have a job that runs every Friday at 9 p.m. So somewhere there's a scheduler that's just looking to go, is it 9 p.m. yet? Is it Friday 9 p.m. yet? No. All right, keep going until eventually it gets there. This is sort of the abstraction I appreciate because I honestly don't care how it knows that 30 seconds has passed. I just need to know that 30 seconds has passed and I need my thing to happen. That's what I need. Here's a sample of a Quartz job. We're trying to use the very similar workflow that we had before. You're implementing the iJob interface. It gives you an execute method that you have to implement. The thing I really don't like about this approach is that you're vendor locked, without a better word, into Quartz. So if you ever get to a case where you don't want to use Quartz anymore, you want to move to Hangfire or Azure Functions or just something else, you have to rewrite this entire method. It's not like the background service or the iHosted service we were showing off earlier, where I could just copy and paste it into another application and it works the exact same way. And generally, I don't care about vendor lock. I'll rewrite the code if I have to rewrite the code, or you abstract the code out into another service and you do the injection here. But I just like to toss it out for folks is you have to do it the Quartz way in order for it to work. But a job's a job. And if you have a timer or a trigger, the trigger will execute every so on. Let's go open another VS Code instance. And this is the same demo. A little bit more startup code, but we're going to specifically set up Quartz, set up a job for Quartz, which is going to be our cleanup temp folder job. And every 15 seconds, we're going to go run that job. We open the job itself. Similar concept. I can use .NET dependency injection. It is not. Well, I take that back. It's one line of code to add the dependency injection job factory. This one line of code takes about 15 minutes to figure out that you have to write this one line of code to do it. Documentation was not very good on this aspect, or I'm dumb. It's one of the two. But once you have dependency injection, you can use your loggers. You can inject all your services, whatever you already have. It should work just fine. These jobs also are instantiated at the time that they run. So if you have something that's, say, talking to a database, you can put that injection safely into the job. It will instantiate the job, run the job, clean the memory up from the job after it's all done. Let's go say .NET run. Make sure that other one's closed. Okay, so this is going to start up our server. They all basically do the same thing with a little bit different logging. And I have the same temp folder I had before. Actually, no, I don't. I changed the name of them all because, or no, I didn't in this case. Sorry. The same idea. We'll go add a file. This time we'll do Excel, right? All right. And we'll go ahead and zoom in here so you can just see everything. So we're waiting. What did I say, every 30 seconds? 30 seconds is an eternity in online talks. But it ran and it deleted my folder. So cool, or file. It did the one thing I asked it to do.
So just a quick question, just to understand, like this is still a .NET Console app, but you're not having to register it as a Windows service because Quartz comes in? Or
no, this is just a ASP.NET Core.
Oh, it's an ASP.NET.
Basically at its
Yeah.
core. No pun intended. But it could be a Windows service. Absolutely. If I wanted to go back to the original demo and use Quartz instead of hosted service, it would all work exactly the same way. The real power, I think, in all these different implementations is not even so much the hosted service platform. It's .NET Core. It's the .NET injection framework where I can set up injections for everything that I want, and .NET just figures it out at runtime. That's the real winner in all this. I think if we were having this conversation back in .NET 4.5 or .NET Framework 4.5, it would be a much different conversation because we would have to be very specific about, all right, I am doing .NET 4.5 MVC, or I'm doing .NET 4.5 Web Forms, or I'm doing .NET 4.5 WPF, because that's a completely different application. Everything's so much more unified now as a platform, and it makes this stuff so easy to do. All right. Now, I don't want to spend a ton of time on Quartz because I'm going to be truthful. I don't use Quartz in production anymore. No particular reason. I've just moved on to other ways that I think are slightly better, a little bit more flexible. But I have supported Quartz on other projects in the past. It's one of those solutions that it works amazingly well if that's what you need. So I like to talk about it. The biggest pro is you have precise scheduling and timing. If you need this run at 3 o'clock every day, you can set up the cron to do that. If you need jobs to run one off, we don't have a demo for it, but remember in Quartz, you have a job and you have a trigger, and the trigger can be on demand. You could have another aspect of your application say, Quartz, go run the cleanup job, and Quartz will go do it as it's able. We could also separate the responsibility from our ASP.NET Core app to a separate job runner. So maybe not doing local file system stuff, but if I'm talking to databases or blob storage or S3 or my own database, I might want to have a separate server that's just for doing work, and it's never going to impact my web server or anything that's client facing. You could do that with Quartz. You could tell Quartz, look at this database for any messages. You could set it up to look at a queue for messages coming in. You can have a completely separate job server from your main application. And I have done that in production, and that works extremely well. A couple cons, you're locking yourself in the Quartz, which probably is not as big of a deal as I'm making it with this bullet. And if you want to tie into some of the .NET Core, .NET features, it's a little bit of extra work. It doesn't just work out of the box like I think .NET stuff should. You have to actually do some configuration and setup. All right, friends, home stretch. Let's talk about Hangfire for a moment. I love Hangfire. Hangfire has been in my toolbox for probably 10 years now, if not longer than that. And Hangfire is a job system for .NET that primarily can give you a fancy UI if you ask for it. And this is one of my favorite aspects, where you can set up jobs and you can see them execute in real time. You can actually go through and look at errors if errors were to occur. You can set up multiple servers that handle all the workflows, and it's all open source for the majority of workloads. There's some paid stuff if you need it, but I've never had an application that really needed the paid licenses. The nice thing about Hangfire is because it's .NET first, it's not a port from anything else. You're essentially bringing your own code. Hangfire doesn't take this approach of go implement iHosted service or go implement iJob. Hangfire says, well, what do you call it? You probably have a class that has a bunch of methods in it, and you want to execute the execute method on a reoccurring schedule. Hangfire lets you do that. Notice there's no colon I something. It's just the cleanup temp folder job class. In my startup, I can tell Hangfire, all right, Hangfire, I want to set you up. I have to back it to a database because it wants to be durable by default. And I can tell it connect to my SQL server. You could also use any ADO compliant database that you might want to use. And I'm going to set up a similar job every 30 seconds. I want to go instantiate the cleanup temp folder job, and I want to execute the execute method on it. And notice this is a generic. We're instantiating our class, and we're running a particular method on our class. We can just tell it whatever we want to, and we can pass parameters into that method if we so choose. They can be, standard integers, strings, you name it. They can also be complex objects. Hangfire doesn't care. We can also do stuff on a scheduled basis. I'm going to run through a couple of use cases, but just for time, I'm going to kind of gloss over some of this. And I want to show you the UI. So let's jump back into a demo.
While you're bringing it up, Surly Dev is here. Good to see
you on Surly Dev.
Twitch. And kind of a dad joke type thing, Hangfire moment. What are you talking about?
Surly Dev, I miss you. All right. Was there an actual question or?
No.
Okay.
Yep.
So
it just reminded me of Hangman from
I should write what's Hangman demo that uses Hangfire.
Yeah. Oh, what's the Tom Cruise? I'm drawing a blank. The jet movie.
Top Gun.
Maverick. Yeah, Top Gun.
Maverick.
Top Gun,
yeah.
Maverick.
Yep.
Hangman.
All right. Same demo as before. You notice a theme here. We just want to look at a folder and we want to clean it up. And there's a variety of different ways to do that. So this time I have just my own class. I'm doing a DI injection or dependency injection, whatever you call it. It's late. I'm getting tired. We go get our temp folder. We look for files inside of it. If we see a file, we delete the file. Yay. I don't think I need to explain this any more than I have. The one thing I've done differently in this demo, because it's Hangfire and it's really easy, I also wrote a method to generate all the files for me. So I don't need to do this part by hand. I could just go run a generate method. Because one thing that Hangfire does very well is I could just go run methods on demand whenever I want to. So look at our program CS just for a little bit of configuration. We have to back it to a database. You can use any SQL database for default stuff. If you want to talk to something that's a little bit more performant, say like a Redis instance, you actually have to pay the license for that. They don't give you that stuff for free. But I have done very well using SQL Server for years and years. No reason not to do that. So the nice thing here is I can say every 30 seconds, go instantiate my temp job class and go execute my method, execute. I can also do stuff on demand. So here's a case where I'm going to Hangfire, telling it I want to run now. So basically in queue to run as soon as possible my temp job class and run generate. And then I have another instance here that runs a schedule. So don't do the work now, but in 15 seconds, go do the work. So it's not necessarily a cron trigger every 3 minutes. I just tell it in 15 seconds exactly, go do this work.
So
And then
as compared to, sorry, I was going to ask, like, as compared to Quartz or other things, this gives you the option of, spinning up a new job, but not doing everything in the job. Like, you could have methods
exactly.
that you can trigger on demand.
Yep. So to be fair, like Quartz can do all the stuff I'm doing now.
Okay.
It's just you have to do it all programmatically, and you don't get the fancy UI out of the box, which I can do right here. I can trigger the Hangfire dashboard. So let's go run this app. Make sure, let's shut everything else down. So let's say .NET run. All right. First thing it's going to do, it's got to go to, I didn't run this demo beforehand. So it's got to go to a database, and it's got to install the Hangfire. I think I failed to, nope, that's all right. Okay, let's do that again. .NET run. But the problem is I've changed my database server like 15 times on this machine, and I don't think I tested it. So I know. Rookie fail. Yep. Yeah. Oh, because I didn't create the database. All right. Can't open the database Hangfire demo because the Hangfire demo database does not exist.
Sean is.
So I did this on purpose to show you all that.
Sean is saying you need to convince Kevin to write Hangfire code that writes my demos.
So I'm going to create a Hangfire demo table or database. And actually, this is a good demo because I can come show you that there's nothing inside this this database.
So this is how you should plan it, not just run it. Just create it on.
Let's go run it. Okay, so it connected to SQL Server. Now, if I come in here and refresh, I have all my Hangfire tables. So it's going to manage its own schema. I don't necessarily recommend putting the Hangfire stuff inside of your existing database anywhere. Make it its own database, completely separate. We don't have time, but I have a story for why I have that opinion. And it's because I accidentally DDoSed myself once. So we will talk about that later. All right, so Hangfire is running. I can go, let's open up a browser tab. So this is localhost and 5148, and we'll go /Hangfire.
I think, Kevin, to Sean's point, like we need this as a separate session, like how I accidentally DDoSed myself.
Oh my gosh.
A full 1 hour.
Yeah. I could do a whole panel on that, man. Just here are lessons I've learned the hard way. And I'll talk for hours. Okay, so we have our Hangfire app. This is the UI that's built into it. If you choose to use it, you can throw authentication around this so no one can accidentally go to a Hangfire endpoint. That's not turned on by default. And you'll see here that we have some filtering for jobs that could run. I am going to go to somewhere.
You're looking for your
yeah, I'm looking. I use a different
content root path. No, that's
I do. Where? All right. You know what? When in doubt, just go look at the code, right? Clean up. So I renamed it. So it's actually going to be this. Go. But. So actually, this is where logging would have helped it. All right. Well, here, let's go run the generate method then. So let me show you recurring jobs first. All right. Let's go run generate. So generate is my method that will create all the files for me. Right. Generate now. Right now. Sam, why did you let me do that? All right, so this is going to go off. It's going to run a method, which you can see here in the nice logs in the UI.
Oh, this is fancy.
The cleanup job generate when and ran. It took 22 milliseconds to run. And what's nice about this is it tells you what it executed. It instantiated temp job folder or cleanup temp job folder job and ran the generate method. And if I had parameters inside of this method, it would show me everything that had passed through. So now this should have, let's go up one. Yeah. So this is the folder. So if I time this correctly,
Kevin, you got some
there.
Friends, like you don't need enemies who can do this to you.
All right.
Yeah,
So that whole time they were dissing me in the comments. You missed the files that showed up in the folder. And now I have to go do this all over again. There. See, I have a bunch of files in this folder. And then what's going to happen here in a second? It's going to process. It's going to clean. It's going to clean itself up. Clean it. Come on. Come on. Hey, I could just go execute it on demand if I want to. Boom, all that stuff's gone.
There you go.
That's another thing you can't do with the other workflows.
Mm-hmm.
You can't go run the reoccurring job on demand, but you can in Hangfire. Now I had generate now. I could always do generate later. And this is going to set up a scheduled job, as we can see here, that will happen at a later time. So scheduled to run in a couple of seconds. Now, if we wait, this will update itself. And usually it's going to be, pretty quick. It does its work. Yep, job is finished. But I was too slow. It added all the files and then it deleted all the files because the system is just too efficient. But just to show you how this thing passes in different folders. So let's go to execute. Let's just add a, let's say string name. So where I have my method here, execute, and we'll say Sam. Every time my application does the cleanup, I'm gonna shut down. There we go. It's gonna pass the name Sam along the way. I say execute. Go look at a example. You see, it shows me the parameters are passed into it. Don't execute Sam. We like Sam. I like Sam too. But we can see the parameters are passed into the methods. And our biggest use case for this is if we have a job fail. So let's make a job fail very quickly. So if, just for funsies, if name is equal to Sam, so I cannot type for the life of me. We'll make sure we actually check this. We're going to throw a new exception. There. All right. If the name is equal to Sam, we're going to throw our exception. It will error out in the Hangfire dashboard. Restart.net. Refresh. So trigger our job. And two things you'll notice. I have a retry up here at the top because the job failed. And Hangfire doesn't like that and wants to retry it again a little bit later. And now this is also a reoccurring job. So it's going to just keep trying to run over and over and over again. These are going to pile up a little bit. But I can come through, see, we tried to execute Sam, but we got a system exception. No, we couldn't execute Sam. Here's the call stack. I can go debug this. I can fix the error.
Yeah.
I could push an update, rerun the job with the same parameters as before, and this will magically work the way that we want it to. So here I can do, let's just take all this out. Let's save. .NET Run one more time. Let's go back into our retries. So we can say, let's requeue this to run. It succeeded because we fixed the exception. Everyone's happy. All right. I spent a little bit more time on Hangfire than I was anticipating, but here we are. The biggest pros of this approach is its precise scheduling and timing. We've used Hangfire and trusted Hangfire to run our jobs exactly when they're supposed to. We love being able to run things one off whenever that needs to occur or kick off some sort of workflow. Hangfire is great for that. I really appreciate strongly typed jobs where I can build my own object, my own methods with their own parameters, and I don't have to build it to a particular system. I can just tell Hangfire, create my class instance, execute my method, and it just knows what to do. Having the UI is a huge help, especially when you have errors. You can go through, look at the different exceptions with call stacks and work backwards to fix everything. A couple cons. So I talked about this earlier. You have to use SQL Server out of the box. It's not the most ideal. There's some third-party add-ons for other databases, but it's open source, so what you get is what you get. If you want something a little bit more robust, you have to pay for the license, which, depending on your project, may or may not be an significant amount of money. And yeah, best paywalls are paywalled. Best data stores are paywalled. You can also set up a separate job server, which is a pain in the butt. Not a discussion for this talk, but I've done it. It works well once you get it set up, but it's a pain in the butt to do. And this guy, Kevin, has a course on Hangfire, which you should totally go buy. Now, we're running low on time, so I'm just going to gloss over this as the last big example. And I have actually taken a lot of our applications that were primarily Hangfire and love Hangfire. I'm never going to say anything bad about Hangfire, but we've been transitioning these background services to Azure Functions because cloud scale. So I always talk about Azure Functions as the last thing because it follows this same concept as, say, we were talking about Quartz, so we're talking about Hangfire, and everything starts with the trigger. So you have the trigger. Yes.
Sorry, before you switch to Azure Functions, real quick, if you're not careful with Hangfire in how you're scheduling it, like what Sturdy Dev is saying, is that a potential? Is that something to worry about?
No. So Hangfire is really good at what it does. The reason I DDoSed myself was that there was a particular bug with a particular version of Hangfire that would 100% dominate your SQL server. So if you had other processes talking to the same SQL server, you would accidentally choke everything out. They fixed that issue.
Oh, I see.
They fixed that issue, but not until I pushed something to production and took production down. So the lesson from that was I never put Hangfire on the same database as my actual database. Our real solution is we have an Elastic pool up in Azure. And so I have main database A, main database B, Hangfire database. Hangfire database is capped on how many resources it can use. So if it were ever to accidentally have a bug in it, it would never use more resources than it's allocated. But other than that, we have never had an issue. We have not had an issue with Hangfire since that. Yeah, but good question. All right. So usually when I don't have such a comedic crowd watching, I get to this part a little bit sooner. But I like to wrap things up with Azure Functions because it's kind of the epitome of everything we've been talking to up to this point. You have jobs you want to do, you have work you want to do, and you want to have triggers that trigger those jobs to do it. And what I love about Azure Functions is it gives us cloud scale. So I don't worry about this running on one particular machine. I don't worry about it running at a particular time. It's all managed for me through an orchestrator, and we're going to touch back on that subject again. And the example code I have on the screen, we're running a timer. So I want something to happen every 30 seconds. Azure Functions is going to manage the lifecycle for me and make sure that this method runs every 30 seconds and does what it's supposed to. But there are dozens of triggers that I could potentially use. I don't have to have just a timer, and I don't have to have just a on demand. I could have events that run whenever I do stuff in Event Grid, or if I'm doing work over SignalR, or if this is an older screenshot, but I could process webhooks. So if a webhook comes in, it triggers a job to be done. There are also custom triggers. So if you're writing your own application and you want to write a trigger for a particular use case that you have, you write your own trigger. There's new triggers for SQL Server or for Postgres. You can write all these different triggers, and they go off and they do the work. And I would sit down and do a demo. I'm not going to do the demo because just the time, but it's not a folder cleanup demo. I'm sorry. It's that's harder to do in the cloud. But I like to wrap it up with just some of the pros and cons that would take you back to Azure Functions. Most importantly, you have very precise scheduling and timing. If you need something to run at 3 o'clock every Friday afternoon, it's going to run at 3 o'clock every Friday afternoon. I love it. There's multiple types of triggers that you can run. Joe, good to see you. So if you don't just need timers, you don't want to write your own, you could just use what's inside of Azure Functions. I love the concept of cloud scale. It's a joke depending on who you're talking to, but it's a real thing. I have another hour talk I do on just basically annihilating workloads with Azure Functions. Like, what if I had 4 million things I had to do immediately? Azure Functions is a great platform to go do that work. My Windows service is not.
Yeah, but it comes at a cost, though, right?
Like 3 cents, Sam. Like, I can do a lot of work for nothing.
Yeah.
Now, on my panel discussion, I will talk about how we've accidentally spent $6,000 in Azure Functions because someone misconfigured it. But that's a story for another time.
We need to have a session of Kevin's accidents.
I thought about writing a book, but like just times I've screwed up. Actually, that $7,000 one, that wasn't even me. That was someone on my team. I just didn't catch it, so I can't take credit for that one. I'm going to come back to the topic of resiliency. The nice thing about Azure Functions is that they're independently resilient. If one of my functions fails, it will be retried automatically, depending on the trigger. If the process running the Azure Functions fails, it's going to start another one. If I have more work than the Azure Functions can handle, it will scale another instance of the Azure Function host. It's like cloud scale. Like that's a very real thing. So I love Azure Functions for all that stuff. The biggest con is, I talk about Azure. So Azure, you need Azure to use it. But the same concepts around Azure Functions, they exist in other places. If you're on AWS, I mean, Lambda is this solution. If you're on one of those other cloud platforms that no one uses, they do the same thing. We can find other ways to do this work. So all that said, if you didn't get anything from this talk, hopefully you're just walking away with the idea of there's certain work that you should be doing in the background, whether it's sending emails, charging credit cards, cleaning up resources, sending reports. I mean, we can go on and on. That's not stuff that should be done on user-focused threads. So the user should never know that these processes are occurring. And hopefully I gave you some tools for your toolbox that you weren't already aware of. And you take that and go do some cool stuff. So thank you all so much for hanging out with me. Oh, I haven't updated the slide since NDC Oslo. But yeah, thank you. It means like this means thanks really in Norwegian. Yeah.
And I think Swedish as well a little bit.
Yeah. Like IKEA.
Yeah. Okay, so maybe off topic, but let's see if I can go back here all the way up. Mr. Panjara, I'm not sure if you're still hanging out with us, but there was an interesting question that I think relates to not just pen testing and cybersecurity, but I think just running your own company.
Yeah.
Hold on, where was the question? So the question is about insurance. Like let's just say you are running
Yep.
a thing for a client, and
Yep.
maybe it's a background service. Like as a independent or running your own show type of situation. Do you have insurance for things like
Yes.
this?
I carry two
Always.
types of insurance. I carry general liability insurance, which is just it's very generic. So if my equipment got destroyed for reasons, like I can use insurance to replace my equipment.
Mm.
If I was going on site, it would protect me like against bodily harm and stuff like that. So general liability. That's not what he cares about. What he cares about is
Getting sued.
you want liability insurance.
Hmm.
So I have business liability, which includes errors and omissions. Basically, it says if for some reason I just screw up royally to the point where there's a business loss to my client, and my client decides to take legal action against me for those cases, I should have coverage, and I do. And I don't mind getting numbers. I have $1 million worth of business liability insurance, and that's because through contracts and through liability, I'm only liable up to the amount that they've paid me. And as much as I like to say, there's very few companies who have paid me $1 million for individual projects. So I'm covered in those cases, and that's probably a great idea to get that sort of liability insurance. Also depends on the country you're in. If you're in the U.S., it depends on the state that you're in, and it depends on the state that your contract is executed in. It's a great idea to get a lawyer on retainer or something just to answer a bunch of these questions. But business liability insurance is really cheap. We're talking, so in the US, $400 a year for $1 million worth of coverage. And they'll also tell you something. It's rare that this sort of thing will happen. But there's been 2-3 times in my career where I have thanked the stars I've had insurance. I didn't have to use it, but I got to a point of panicking where I'm like, I'm glad I have this just in case, because I thought I was going to get sued for something that went wrong. So
Well,
thankfully that stuff didn't happen. But there's been a number of times I'm like, well, I'm glad I have my contract and I'm glad I have my business insurance, because that sucker has, it's paid for itself just in terms of like no
your
sweat off my
sanity.
brow.
Yeah, exactly. Yeah.
Because the thing that they send you, the first page says, all right, if for any reason a client or customer brings a suit against you, you call this 800 number. And that 800 number connects you with the insurance company's law department. Like, insurance companies hate losing money. Like, they are going to bend over backwards to make sure you don't have to pay. So they are your advocate in that case. I still have a lawyer on the side just for everything, but I let the insurance company deal with the insurance stuff if it were to come up. But for pen testing, absolutely have insurance, but also have a really good terms of service agreement and in a contract, basically saying, where our results are not guaranteed. Like,
no one can.
Yeah, no one can guarantee results in those cases. You can do your best, do your due diligence, but if they, got hacked because someone screwed up afterwards, that's not on you.
Yeah.
Good question.
Yeah, real stories from the trenches. So thanks,
Yeah.
thanks big time, Kevin. And chat room, you've been amazing. Let's bring your big faces up here. Surly Dev, Joe, and Sean, and everybody else that I'm forgetting. Blazer, Mr. Magoo, thanks for hanging out with us. This has been great. Like you said, Kevin. I mean, it's a group of friends, and we are here to heckle, makes your talk a little bit more engaging and funny. And you might slow down a little bit, but we are having fun. So
I'll drop links to all the resources in the chat for everyone.
Absolutely. And then if you, I can copy those out and put them on the meetup site as well.
Cool.
Yeah. All right. There's Kevin here from Udemy Courses. Yeah. Yeah. Who heckles? Yeah. All right, people.
Love you, Sean.
It's past dinner time for Kevin and me, so we'll go
eat
some, and hope you have a good rest of your night as well. Yeah. And thanks for hanging out with us, Kevin. Thank you so much for spending your evening with me here.
Absolutely.
Our friends appreciate, and thanks for all the knowledge drops. We love you. So thank you.
Thank you, Sam. Thank you, everyone, except Surly Dev. Thank you. Yeah.
We'll see you on the next stream, folks.
Y'all take care.
Take care.
Bye.